Simplify these expressions then. Let's have a look. There's an x common here on this fraction top and bottom, so cancel that out. It just leaves 7 over 2, doesn't it? Here there's an a common top and bottom, so that's just 5 over b. Here there's an x common top and bottom, isn't there? Just one of the x's on top. So it leaves 12x over 4. 4 can be cancelled top and bottom to leave a 3 on top, can't it? So we're just left with 3x. Here there's a 5 common top and bottom. 5 goes into 15 3 times. One of the x's can be cancelled with the x on top. So we're left with 3 over the x squared. Okay, let's have a look what's common top and bottom here. One of the a's cancels here to leave a squared. The b squared can cancel, both of them cancel top and bottom, and one of these c's cancels here and here. So we're left with a squared over c squared. Right, now nothing seems apparent to be cancelling top and bottom, but if we factorise top and bottom, we'll see if there's any common factors. So there's a 3 common on the top, so we can take that outside a bracket, and we have this, don't we? And then underneath, if we factorise it, 4 ones, x plus 4, x plus 1. So that's now factorised. Now we can see that there is an x plus 4 common top and bottom, and it just leaves the 3 over x plus 1. This one now, 5 threes, the difference is 2, so hopefully that will factorise with 5 threes. 5 threes plus 5 minus 3 will give a difference of plus 2, won't it? Underneath, we've got a 2x and an x. It's got to be 3 ones. And let's try it that way around. It's minus 5, so let's take minus 6 plus 1 is 5. See it? Minus 6x plus 1x is minus 5x. Now we can see, now we've factorised, there's a common factor top and bottom. So we get x plus 5 over 2x plus 1. Here, x over x plus 1, there's nothing readily apparent common top and bottom, is there? We could do something with that, but it's just not, from this point of view, there's no simple common factor here readily to hand. So that would be the answer then, wouldn't it? Just that as simplified. That's good enough. Okay, let's have a look at this then. Just a little reminder before we go on to this algebraic corresponding bump. Fractions, when you times them, you times the top, 2 5s are 10, 3 7s are 21. 10 over 21. Here, remember we'd divide one fraction over another. This 3 drops down to be with the 5 to make 15, and the 7 swings up to the top to be with the 2. 7 2s are 14, and the 3 5s are 15, so we can write 14 15ths. And the same correspondences apply to algebraic symbols as well, of course. The same rules apply, because they're just numbers. So this fraction times this fraction, we times the top, AC, over the product of the bottom BD. And here, same process applies. The D swings up to be with the A, and we can write A times D. And then the B drops down to be with the C, and we can write BC, so that's tidied up there. So those are the rules then. Let's have a look at these problems. So here, 3 times 18, A on top, and a BC on the bottom, isn't it? This B swings down to be with the 3, and the C swings up to be with the 6A. So 6a times c over 3 lots of b. And x cancels top and bottom here, and we're just left with 8, aren't we? Okay, now this x swings up to be up the top. So we get 4 times x, which is 4x squared over 2. And then a 2 cancels top and bottom, doesn't it? So we get 2x squareds. Here a b is common. So we can cross off one of those top and bottom. We end up with 8, well there's a 2 common as well, so that's now a 4. So we get 4a squared b on top. Now just 1 underneath, so that's just 4a squared b. Because there's always a 1 times something underneath, isn't there? So it's over 1. And we don't write over 1, we just put the number on top. Okay, the 2 drops down, the b swings up, so we've got ab cubed over 2 times 8 is 16a. Yeah? Now the a's cancel, and we're left with b cubed over 16. Next one, we've got this times this, 3 over this, and x cancels, top and bottom. I'll just cross it out like that. One of the y's cancels, cross that out there. And 2 of the z's cancel here, and we leave just the z. So we're left with 3zx, so we can write 3xz, can't we? And there's nothing underneath, so it's just 3xz. Oh, there is a y left here. See it? It's just y. Okay, good. This stuff swings up to the top, so we get x, this stuff times this stuff, so we're going to get x cubed. We're going to get y cubed. And the z, all this stuff here swings up to the top, so we'll end up with z to the 5 over 3. Right, so now let's have a look at these final little few examples here. When we added fractions from before, we cross multiply 3 plus 2, 2 ones are 2, over the product of these two, 2 threes are 6, so we end up with 5/6. And when we took them away, it was 4 ones are 4, minus 2 ones are 2, over 2 fours are 8, so that was 2 over 8 then, which you can simplify down to a quarter. So that's how we do fractions. Well, the same applies to algebra. We can cross multiply. So when we're cross multiplying and we're moving things across, there's more than one term on these parts, so put a bracket around them. 3 lots of that, plus, just get rid of this, we'll do this in a minute. So it's 3 lots of that one, plus 2 lots of that one, so I'm just cross multiplying over the product, and 2 threes is 6. Expand the brackets then, 3x plus 3, and then 4x plus 2, plus 4x plus 2 over 6. And now we can write down that would be 7x, I'll just put it here. So it would be 7x plus 5 over 6. Okay, so let's do the next one. I'll just get rid of a little section and we'll do the next few. Create a little bit more room here. That'll be fine. Now let's write down the next example. Right, here's the examples then. Well, we could do this by just timesing by x top and bottom here and having the same fraction if we wanted. So there's two different ways of, if we get x over x squared, that would be, or we can cross multiply. So I'm just going to cross multiply here. X squared plus 4x on top over x times x squared is x cubed, and that's equal to x plus 4, isn't it, over x cubed. One of the x's will cancel to leave x plus 4 over x squared. Now I'm going to look at that problem again and just do the alternative method. And now, because it's slightly easier to use the alternative method in this case. So let's just do it then. Change this to equivalent fractions with x squared underneath, times by x top and bottom. So it'll be x over x squared plus 4 over x squared. Now we can just add them as though they were fractions with the same denominator. So it's x plus 4 over x squared. So that's the easier method in this instance. Next one, cross multiply, 3a plus 2's minus 2 lots of a plus 1's, more than one term, so I put a bracket around them when I'm moving them, over the product of these two, more than one term, so I put brackets around them when we move them and multiply them. So here what do we get? We get 3a minus 2a, it's just a, and then we get 6 minus 2, don't we? So that's going to be 4, so I just, because I haven't got much room, I'll just put a plus 4 over a plus 1, a plus 2. This one, again, it's very akin to this. If we can just get b cubed all the way through, so if I times this by b squared top and bottom, it will be 4b squared over b cubed. And this one times by b top and bottom, we'll get plus b over b cubed minus 2 over b cubed. So we end up with then, now we've got the same denominator, we can just combine them. 4b squared plus b minus 2 all over b cubed.